guys. So now that we know that x is equal to 45, we can plug it back in. Okay, so we need to plug it back in. So we need to do 2 times 45, which 2 times 45 is 90. So this equals 90 degrees. Okay, and this one, it's just x, so that equals 45 degrees. Okay, guys. So this one's going to be a little different, okay? We don't have an equation for every single angle, but we do have an equation for half of it, and half of a circle is 180. So we're going to add together the 2x, the x plus 5, and the 4x and set it equal to 180 to figure out what x is. So I'll do this in a different color. 2x plus x plus 5 plus 4x is equal to 180. Okay, then we got to add our like terms. So 2x, x, and 4x. So 2x plus x is 3x. 3x plus 4 is 7x. So 7x. Okay, and then we kind of just bring down the 5 because there's not another like term. That equals to 180. Okay, then you got to subtract out the 5. So we've got 7x equals to 175. And then we have x, okay, then we got to divide by 7. And x is equal to 25. So x is equal to 25. Then again, we got to plug it back in, okay? We've got a bunch over here, so we need to do 2 times 25, and that equals 50. So this one is equal to 50 degrees. Then we got to plug in x for this one. So we're going to do 25 plus 5, and that equals to 30. And then we can plug it in over here. We can do 4 times 25, and that equals to 100. So this one equals to 100 degrees. I will put the 30 in here. Sorry, I forgot to put the 30 in. And then we can do 6 times 25. And 6 times 25, that equals 150. So this is 150 degrees is in here. But we still need to find this angle right here that I've just marked in green. So what we can do is we can add all the other angles together and then subtract from 360. So let's take the 50, the 30, and the 100, and I'm going to come down here and add it together. So we'll take the 50 plus the 30 plus the 100 plus the 150, and that equals 50 plus 30 plus 100 plus 150. That equals 330. So that equals 330. And then you can take 360 and subtract out 330, and that gives you 30 degrees. So this one right here in green is 30 degrees. Alright, guys. Like I said, pause the video if you need to. Alright, let's keep going. So an inscribed angle has a vertex on the circle and endpoints on the circle. Okay, so a central angle is in the middle. An inscribed angle goes all the way across the circle. The measure of an inscribed angle is half the measure of its intercepted arc. So, to put that into mathematical terms, the measure of angle PON is equal to 1/2 the measure of arc PN, or NP. Okay, So if you look here, right, this arc is 50 degrees, or it's 100 degrees. Half of 100 is 50. So this angle is 50 degrees. Okay, guys. So it says find the value of the missing angle or arc measure. So, all right, let's find the measure of angle ADB. Let's start there. Okay, so we need to find, and I'm going to mark it in blue. So we need to find that angle. So that is equal to half of the arc. So half of arc AB. So the measure of angle ADB is equal to 1/2 of 76. And that is equal to 1/2 of 76 is equal to 38 degrees. So this one in blue is 38 degrees. All right, now we need to find the arc DC, which I'm going to mark in red. We need to find that arc right there. And so we can use the same formula and kind of fill in our information. So same formula. Okay, we're just going to change the what angle we're working with. So we're not working with angle ADB now, we're working with angle DBC. So we're working with, and I'll mark it at 45 degrees. I'm going to mark it in purple. So the measure of angle DBC is equal to 1/2 the measure of arc DC. Now we know what the measure of angle DBC is. It's 45 degrees. So let's fill in our information. So 45 degrees is equal to 1/2 the measure of arc DC. So we want to, this is like multiplication. And to undo multiplication, we do division. So we're going to multiply by 2 on both sides. Right? And those cancel. So 2 times 45 is 90. So 90 degrees is equal to the measure of arc DC. All right? So this arc DC is 90 degrees. Awesome, guys. All right, guys. So let's work on this next one. All right? So question mark, all right? We need to find that arc, or this angle, the question mark angle. So, but first what we need to do is find this arc right here. So we need to find this arc in green in order to find the question mark. So to find that arc, okay, we're going to add the 113 and the 179. So let's do 113 plus 179. And that is equal to 292. Then we're going to take 360 and subtract out 292. And that is going to give us 68 degrees. So this in green is 68. Okay, we're going to use that same kind of type formula where the measure of the angle that's in the question mark is equal to 1/2 of 68. It's going to be equal to 1/2 of the arc. So it is equal to, remember that's multiplication, so that is equal to 34. And you can do this in your calculator by taking 68 and just dividing by 2. So if you took 68, I don't know if you could see that. Maybe. Yep. So 68 and you divide it by 2, you get 34. Awesome, guys. Let's keep going. So an inscribed angle with the same endpoints with exact will be exactly half the central angle. So if you see here, we've got central angle HOL. Okay, so the inscribed angle HAL will be half of 98. Okay, so the measure of angle HAL is equal to 1/2 the measure of angle HOL, and that is equal to 1/2 of 98, which is equal to 49. So the measure of angle HAL is 49 degrees. Now the way this kind of works out is because a central angle, right, HOL is 98. So this is 98 degrees. Well, this arc HL, is also 98 degrees because it's a central angle. And central angles are the same measure. The angle is the same measure as the arc that it intercepts. That's how that kind of works out, okay? So, make sure you write this stuff down. Two inscribed angles with the same endpoints have equal angle measures. So if you see here, right, we've got this one in blue and the one in red. They have the same endpoints, which means that the angle of the red one is going to be congruent to the one in the blue. An inscribed angle with endpoints on the diameter, so it's got an endpoint on the diameter, is 90 degrees or a right angle. So this is a right angle. A quadrilateral inscribed in a circle has supplementary opposite angles. So that means this angle and this one are going to add up to 180. Okay? These are going to add to 180 degrees. Okay, let's keep going. So find the value of the variables. So we're going to take, okay, these are opposite angles, so 3x plus 2 plus 3x minus 32 is going to equal 180 degrees. So like I said, add your like terms. So 3x plus 3x is 6x, so 6x, and then 2 minus 32 would be minus 30 is equal to 180. And we're going to add 30. And 2x, or 6x, is equal to 210. And then you're going to divide by 6. Divide by 6. X is equal to 35. Okay, x is equal to 35. We need to plug it back in. So we're going to do 3 times 35 plus 2. So 3 times 35 is, oh man, hold on. So that's 105 plus 2, and that is equal to 107 degrees. So this is 107 degrees. Then we also need to plug it in for this one. So 3 times 35 subtract 32, and that is equal to 73 degrees. Okay, so this is equal to 73 degrees. Alright guys, the next video is just going to be like a bonus video. Alright, I'm not going to require you to take notes on it, but if you need some additional practice and some extra support, it's there for you. Alright, thank you.